I'm Elwyn Berlekamp. The slides accompanying this video are being posted on my website. I was a high school student when Martin Gardner wrote his first mathematical games column for Scientific American. I followed his columns there for the next 25 years. I co-authored a book called Winning Ways, which we dedicated to Martin Gardner. After another decade, I became involved in organizing each of the first 11 gatherings for Gardner. I was delighted to participate in the 12th, and I'm sending you this video in lieu of my being physically present at the 13th. In 2000, I was troubled that so few people realized that combinatorial game theory could be applied to many popular games that non-mathematicians actually played. So I composed a problem intended to dispel that misunderstanding. It was entitled 4 Games for Gardner. Many people will recognize these as positions in chess, Go, and checkers. This 4th game is now called domineering. Some old Martin Gardner fans might also recognize this as a position in the game he called cram in the February 1974 issue of Scientific American. Studies of this game can now expose the foundation of a branch of mathematics called combinatorial game theory. Here is one shelf of books that have been written on that subject. I'll now use these games to provide an overview of that subject. I'll now call the domineering players red and blue, or equivalently, right and left. In this game, red, at his turn, must place a single red domino horizontally onto a pair of empty adjacent squares. Blue, at her turn, must place a single blue domino vertically. Once placed, the dominoes can lose their colorings. Each of these 2 moves has reserved a space into which only one player can play. A region which is reserved for a single blue domino is assigned a value of +1. A region which is reserved for a single red domino is assigned a value of -1. Combinatorial game theory assigns more complicated values to more complicated regions. Each of these values represents a data structure that depends only on that local region. The value of the entire board is the sum of the values of its regions. More details about how to do this appear in the full version of this video, which can be seen during the break. Although each of these 4 problems has some interest in its own right, combinatorial game theorists find it more interesting to play them all together. At your turn, you can choose to move on whichever board you wish. Richard Guy calls such a sum of different games a Gallimaufry. You win when your opponent at his turn has no legal move, but the scope of other rules may need further resolution. Does the compulsory jump rule in checkers ban only non-jump moves on the checkerboard, or does it ban all other moves in all component games? The outcome of the Gallimaufry might also depend on the scope of the co-ban rule. I'll leave that as a problem for the assiduous viewer. The initial version of this problem was published in G4G's 2nd tribute volume, co-edited by Tom Rogers and David Wolf. I abbreviated that title as 4G4G as my contribution to the numerology of that gathering. I extended it to become the title of a paper in the 2nd volume of Games of No Chance, but I now think that title was mathematically incorrect. It might have been better to emphasize the Gallimaufry. But the video I've been preparing is going for G4G13, so the more appropriate abbreviation of the title of this video is this, which I hope might be viewed by our numerologists as another fulfillment of their prophecies. Thank you.